if a company was wanted to take advantage of the security of a blockchain, this is like the end state of what that would look like for them. Like, if it's not going to happen, if it's ever going to happen, it's going to happen this way versus what is currently out there today. Today, we're going to talk about our new paper, vApp, which is a verifiable app at internet scale. But before I get into that, I think I need to explain some underlying background, right? So, like, for developers building on blockchains today, and like the most popular blockchains are usually EVM, right? For actual applications to be built on them. It is written usually in Solidity. And so what happens is application developers need to learn Solidity. They write their code and it compiles into bytecode that gets run on, say, Ethereum. And running code, learning doing this, they have to learn the complexities of what gets written, how to write on Ethereum, and the problems with atomicity, parallelization, cost of storage, security vulnerabilities. It's a whole new way of thinking how to develop, right? It's not just any Rust developer can come, or anybody off the street, classically trained in computer science, could immediately just build an application that's secure that could run on Ethereum. There's a lot, the barrier to entry, there's a lot to learn. There's a lot of risk, right? Most applications are built that hold some type of financial value. Because of that, it is a scary proposition for a new developer to come into the space. So there's that. On top of that, beyond the security and the learning curve, it is actually quite expensive to run applications on Ethereum. So you don't see very complicated applications being built anymore there, as the costs have gone up, right? And so developers and blockchain builders are trying to think, spent the past few years trying to figure out, how do we scale this? Ethereum's not good enough. How do we scale, how do they scale Ethereum? And so the approach to scaling Ethereum is you build a layer 2. And so what a layer 2 is, most layer 2s, like arbitrary optimism, are just the EVM itself that is being run off-chain by, say, a sequencer, and then they are committing to Ethereum. So in the optimistic state, they're committing a state root with transaction blobs that then somebody can prove if that state root was incorrect. By a watcher could prove that it's incorrect and invalidate it, right? And so what that does is that moves the compute and storage costs and all of that off of Ethereum. So it reduces the cost here, but you still have the problem, right? Developers still need to write in Solidity. They still need to think about all of the risks associated with coding smart contracts, thinking about how they're going to lay their storage out, not having parallelization, or threading or anything like that. There's a bunch of learning curve and barriers there. And then things that just can't be built in that environment due to the sheer complexity, right? And so this still, although fixes the cost, does not fix that major problem of how do we bring Web 2 applications, how do we bring everybody to build on a blockchain and take care of take advantage of that security. And so this inspired, the layer 2 has inspired the concept of what vApps are. And what are vApps? So vApps are applications written, say, in Rust, which is one of the most popular languages out there for computer scientists. And you get to write your custom code like you would write for any Web 2 application. And then that code interacts with an SDK, that is the vApp SDK, which will generate zk proofs to be able to commit to, say, an Ethereum. And the application developer themselves don't need to know anything about the zk or blockchains or any type of things that they have to think about here. They could just write their application like they would for Web 2 and then automatically get the security of that layer 1 for what they want. And even further, right, they can build, they have this huge app, say like Facebook or Uber or something like that, and they only want a subsection, right? So section B out of A, right, that they want committed to the blockchain. They don't have to, and they don't want to verify the rest of their application, and they don't want to pay that cost. And they don't have to build this whole thing within that. They could just build a subsection that is built on top of the SDK that writes to Ethereum, and then an intermediary layer that connects to that. And their whole app has that unified experience where the user doesn't even know what is or what isn't being used or written to a blockchain, but they get to have that verifiable proof that part of whatever they've written, the part that matters to them to verify, is being secured by, say, Ethereum, which is a huge unlock. And another part, right, to think about is since they are writing in Rust, right, and then this is converting to this is creating a zk circuit specifically for their code. It is far less complex than, say, an L2 that has zk, right? Because when an L2 using a zkVM, you have to write the entire code base to run the entire virtual machine, Ethereum virtual machine, which has way more opcodes, which is far more complex. For example, to do a Fibonacci, which is a simple piece of code, it was 800 times more when written in EVM than converted to a zkVM than it would be to write it directly in Rust to an SDK and then to Ethereum, right? And so the code complexity is far smaller, the proofs are smaller, the cost to generate those proofs are significantly less, making it much more affordable, faster, and more secure because there's less code, right? To write an app of vApp than it would be to write a zkL2 or build on a zkL2, which makes writing vApps the closest path to getting, the benefits of zk and the security of zk without that very high risk that is associated with zkVMs today. So that's like the whole vApp idea kind of in a nutshell. You have anything to add, I'd say?
I think it's a very good intro into the overall idea, the main value proposition. Like I would like to extend it a bit further, talking about the other side of the technical property that are not possible given the current construct, and also like the implication. So the first part of it would be privacy. Privacy. So now like you don't need to follow the rules of L2 being publicly verifiable. Anyone can want to know, right? You can hide a lot of your input behind the witness, a very unique property of a zk here. And then the second thing is customization. You also don't need to follow the rules of L2 having gas limit, block limit, nonce, or paying with the gas native token, right? You can do whatever you want. You can have like you can make it gasless, or you can make it like a paying with USDT, anything you want. And third is scale. So Raz talked about compiling the Rust native code to the zk circuit versus compiling L2 on EVM to a zk circuit. He's talking about 800x difference. And we're talking about a very benign, simple program, right? And that scales, as capacity scales. And with everything standardized, you can add more precompile into the circuit to run a certain logic more quickly. And we showed that in the paper that with a precompile of certain operation, you can have another 20x of the time. And that all these things stack together. And we're not counting the improvement of the hardware, GPU, CPU, like ASIC circuit. So a rough math tells us that we're looking at the capacity at a scale of like a 10K to 100K. So the B can be way more complicated than the app you see today by this much. And another very important property that ties back to layer 0 would be the interop, of course. Because right now we standardize the messaging interfaces between these apps. Let's say this is Uber, right? And you can also go to Facebook. Facebook, you log in and then you do the payment for another large G, right? And this thing can talk to each other through layer 0. And together, they weave into a huge network fabric that paved the way for like unlocking Web 2. Hence, like the paper is titled Verifiable Application at Internet Scale.